Good morning, everyone. I'm Michelle Sanner, and today we are going to talk about chemical structures. And we're going to learn a technique called electron dot notation that kind of organizes and keeps track of valence electrons. And then later on, after this video, we're going to see how using electron dot notation can allow us to predict the shape of different molecules. So let's start with chemical bonds. In our last video, we talked about the different types of chemical bonds we're going to be studying this year. A chemical bond is an attractive force that holds atoms and ions together. You can have ionic bonds, which are the transfer of electrons, and those all occur between metal and non-metal elements. You could also have polar covalent bonds, where there's a sharing of electrons, but that sharing is unequal in nature. One of those elements is better able to attract electrons to itself compared to the other element in the bond. And those occur between metal and non-metal substances. Then we discussed non-polar covalent bonds, which is a type of covalent bond in which there's equal sharing of electrons. Those occur between nonmetals and nonmetals. When atoms bond, they create something called a molecule. So a molecule is made up of, two or more atoms. You can have different atoms, you can have the same atoms, but when things are bonded together, we call that a molecule. So a molecule is the smallest unit of a substance that keeps all of its physical and chemical properties of that substance. For example, to take the molecular formula of water, H2O. Water has different properties than the things that make it. Oxygen, hydrogen. You can't breathe water, but you can breathe oxygen. So this is the smallest that you can get, down to one single molecule of water. Once you start breaking that water apart, it no longer exists as water. It exists as something else. And that something else has different physical and chemical properties. So atoms, as you recall, tend to bond together when it's energetically favored, when they can minimize their potential energy and achieve more stability. That's when atoms tend to form. One thing that I need to discuss today is a molecular formula. And this is a chemical formula that shows the number, so the quantity of different types of atoms in a molecule. It doesn't tell us anything about how those atoms are put together, but it does tell us a little bit about what those molecules are composed of. For example, H2O is composed of two atoms of hydrogen and one atom of oxygen. And when you don't see a subscript down below, it's implied that there is a one there. We tend to leave off the one, and it's implicit that there's only one of that type of atom. So in other words, this molecular formula is like a shorthand way of describing how many of each type of atom exist inside that molecule. And as I pointed out, H2O has two hydrogen and one oxygen. Note that the number one is implied. This compound right here has an implied 1 phosphorus and 3 chlorines. Here we have an implied 1 nitrogen and 2 oxygen. And remember, we don't write these implied ones when we write a chemical formula or molecular formula. We just write the single symbol. So note that this subscript here refers to the number of that particular type of atom. And I always think of subscripts like submarines, right? They're down low, they're down below the number as opposed to up above. So remember our octet rule, this idea that atoms tend to want to form a stable octet of 8 valence electrons. And they do that by either gaining, losing, or sharing electrons. And that's because those electrons in the highest energy level, remember that they're held less tightly to the nucleus of their own atom, and thus they're able to move around just a little bit more freely and be transferred and shared between 2 or more nuclei. And the reason that things tend to form in this octet of 8 valence electrons is because, like all things, it's looking to achieve stability and minimize potential energy. So in doing so, in sharing 8 electrons, this molecule is now able to achieve its stable 8 octet and reduce its potential energy. So remember that covalent bonds are sharing those electrons, which allow them to obtain that full octet. And those are both polar and nonpolar bonds. So now let's talk a little bit about some notation. In electron dot notation, only the valence electrons of an atom of a particular element are shown. The valence electron is represented by a dot. And the inner shell electrons, those electrons that are not the valence electrons that live closer to the nucleus, they are not shown, they are implied. So this first step in electron dot notation is to write the chemical symbol. So let's pick a chemical and try this out. Let's do, how about carbon? So first let's figure out how many valence electrons carbon has. 1, 2, 3, 4. It's in the 4 valence electron column. Carbon, and I'll just write over here 4 valence electrons to remind me. So step 1, write the chemical symbol, check. Step 2, identify the number of valence electrons, check. In step 3, and this does matter, starting at the top and moving clockwise, we're going to place those electrons on all 4 sides until we run out. So we have 4 valence electrons, so I'll go 1, 2, 3, 4. Notice that I made sure that all sides have 1 electron before adding more. And in this case, we don't have more. But let's try one that maybe has a little bit more valence electrons. How about, let's do chlorine here. And it has 1, 2, 3, 4, 5, 6, 7 valence electrons. Chlorine, 7 valence electrons, starting at the top and moving clockwise. 1, 2, 3, 4. I want to stop and make sure that all of my sides are covered before moving on. 5, 6, 7 valence electrons. So you see there's a little empty space right there because we have not yet achieved our full octet. All right, step 1, step 2, step 3, all set. So we'll try some examples. We just did carbon. Now we'll do fluorine. Moving to the periodic table, first find it. I see that it also has 7 valence electrons. Starting at the top, moving clockwise, 1, 2, 3, 4, 5, 6, 7. And you'll notice that there's a little technique I use where I kind of I double them up neatly, top, bottom, right, and left. And so I'd like you to use that technique as well. Pause the video for a second and see if you can write the electron dot notation for hydrogen and for sodium. I'll put the periodic table back up. All right, so how did you do? Both of these have 1 valence electron, so you would just write the chemical symbol and place that valence electron up top. Pretty easy. So that's it. That's how you use electron dot notation to identify the number of valence electrons. Next time we meet, we're going to discuss how do we put these together to start predicting the bonding angles, the way that atoms are going to bond together to form that stable octet. So hope you took good notes and you're having a wonderful day, and I will see you next time we meet.